Greetings, SC21 participants, and especially greetings to SC21 teachers. My name is Bob Gottwals, and I am a computational scientist and computational science educator at the North Carolina School of Science and Mathematics. We're located in Durham, North Carolina, and we are a 2-year state-supported residential and online program for academically gifted juniors and seniors in the state of North Carolina. So today's talk is entitled Jane Austen Meets Computational Science. And I'm going to be talking about how we're using computing and computational science to teach the humanities. We have developed a course called Digital Humanities, and I'm going to show you some examples of some activities that we do in that course. So give me a second, I'll turn the screen share on so we can see what's going on here. There we go. And we now should have a screen share on. So, I don't want that. So, there we go. So a little bit about our program in the computational sciences, just to set a little context. We think we are the largest program in the computational sciences in the country. We have 11 courses, including 2 courses in research, one for the online students and one for the residential students. A number of years ago, we responded to a request for some interdisciplinary courses. So a member of our world-class humanities department, Michelle Brenner, and I put together this course in digital humanities. We've been teaching this course now for several years. And the goal of this course is to try to bridge that gap between the students who come to a school like ours who really identify as being science, math, computer science kids, and interestingly enough, kids who come to our school who are coming because we have a world-class humanities program. So what we wanted to try to do is bridge the gap between those 2 groups of students. So what I'm going to do is show you a couple of examples of programming that we use with the kids in the digital humanities course. So I'm going to start out with Mathematica. We are fortunate to have a site license for a piece of software called Mathematica. It's a very well known, if you know of Stephen Wolfram or you've heard of Wolfram Alpha, that's the Mathematica software that company developed. So you see here, what I've done is we've imported all of the text from Pride and Prejudice, and we've done some statistical and computational analyses of that text. So we start out by doing a word cloud, which of course the words that are the most frequent words in that text are the biggest, and we have them color coded to make it easy to read. There's lots of ways to sort this, so I could very easily get rid of all of the Misters or get rid of all the Elizabeth to try to see what other words we get here. We are able to do extract by sentences. So you see here, there's a very simple Mathematica command, text sentences, which extracts all those sentences out. And I can look at text structure, which is not something we do very much anymore. So I can look at verb, preposition, proper nouns, noun phrases, all of those types of things. I can also use Mathematica has a very cool embedded natural language processing or NLP capability. So I can use that. I can just type in Jane Austen. It's not a command, but with the NLP engine underlying Mathematica, it will go and find various things here. So you see, I use the person data command, which is a Mathematica command to go find Jane Austen and her notable books. And what came out was this list of books here. And then I can do some interesting things like I can come up with a timeline plot. So I can see where, when she was born in 1775, and then I can come up and I can see when various books of hers were published. So this is just a very simple demo of how you can use a tool like Mathematica to do analyses of literature. We also have a fairly big project, and we developed a data set of Civil War battle data. There's a spreadsheet of Civil War battles that comes out, was put out by the U.S. National Park Service. So we were able to capture that data and do some computing around that. I'll scroll down to some of the more interesting things here. So we were able to do some descriptive statistics where Union casualties, Confederate casualties, total casualties. We can look at the mean, median, standard deviation, min, max, and quartiles for all those battles. We can do, and you can clearly see this is a tutorial file. So I'm teaching the students here how to use various commands to do things. So we can plot a number of things. So we can plot Union deaths versus Confederate deaths. And I have turned on in this particular thing a neat little Mathematica feature called Tooltip, which allows me to hover over any data point here, and it will tell me what battle that was. So if it was interesting, the kids really did not know a whole lot about the Civil War, even though we're here in the South, and they really did not know a lot about Gettysburg, the Battle of Gettysburg. So they were very interested when we plotted this. And we look over here at a lot of Union deaths and a lot of Confederate deaths, and we hover over that point there, and they see that that was Gettysburg back in 1863 or so. We can do some statistical fitting of this. So we came up with that we could predict the number of Confederate casualties based on a linear regression, y equals mx plus b. So 0.745 times the Union casualties plus an intercept of about 304. And that's not a very good fit. It's about a 66.66 R squared value, but it's still pretty interesting. Okay, so we again did another plot there. It wasn't a very good fit. So we went and we did an exponential fit, and we were able to get a little better data there. I can look at we can put together some charts. So I did Union, Confederate, and total casualties there. We did this by state. So no surprise that Virginia was where most of the casualties were. And this really surprised the kids when we did this. Mathematica has very good mapping capabilities built into it. So I did a geo-region value plot. And when we plotted all of the battles, obviously lots of them in Virginia, they were very surprised to see that there were some battles out in Idaho and North Dakota and other places other than just in the South. Obviously, Tennessee was a big place, but that was very surprising to the kids. Again, we did some tallying here. We were able to develop a chart: decisive influences, impact on the war, impact on the particular battle, observable outcomes, those types of things. And we were able to plot the number of battles by year. So you can see that 1864 had the most battles with 68. We did I showed them how to do some filtering there. And then finally, we just did a listing of all the battles in the war. We also did a talking about more recent things, we had the students take a look at some of the issues related to the Trump-Russia network. And so we were able to find some data from docs.com. And again, this was a tutorial. So you see lots of tutorials here. But when I get down to it, what this does is it says every time somebody has a relationship, we record that. So Julian Assange had some affiliation with the DNC. He had some affiliation with the Russian government. Michael Flynn had obviously connections with Donald Trump and a couple others. This was a short version of this data set. And then what we were able to do is calculate different types of scaling. One is a degree scaling, which is the number of contacts. So obviously Julian Assange did not have any contacts with himself. And then what's called a between the scaling and the amount of influence. And we were able to plot those using what's called a degree centrality network, where the larger the sphere, the more active the connection was. So there was a degree centrality network, and there was a betweenness. And so you see in the first one there, Vladimir Putin is not very big compared to Trump. But if I look at the influence of between the centrality network, Putin and Trump are pretty big. And then we were able to separate that all out so we see some of the actual data there. So in addition to Mathematica, we do have the kids do some programming with more traditional tools. So here is using the tool called R. And interestingly, that there's actually a R library or package called Jane Austen R, which is what I used for here. So this is where we're getting the kids to actually learn how to write code. We're using tools like tidyr and tidyverse and ggplot2. And when we do that, we get a variety of pretty interesting plots. So here's a sentiment analysis. Some sentences are positive or sentences are negative. There's a representation of some of the most important words, which ones were negative in sentiment, which were positive in sentiment. We did a word cloud there, just like I did in Mathematica. So R has a word cloud thing built in. And did I do another here? Yeah, there's another sort of a word cloud trying to focus in a little bit. So we did look at text analysis using both Mathematica and using more traditional tools like R programming. So that's the program we're doing here at the North Carolina School of Science and Math. We're very proud of our digital humanities program. And I would very much welcome most of the teachers that are probably attending SC21 are most likely science teachers, chemistry, physics, biology, because that's what most people think high performance computing and computational science is being used for. But if you're attending this session and you're a science teacher, or more importantly, if you're a computer science teacher, I would encourage you to walk down the hall, find your English teacher, find your literature teacher, find the art teacher, find the history teacher, and talk to them about the use of computing in the humanities. I'm Bob Gottwalls at the North Carolina School of Science and Math. My email is gottwalls@ncssm.edu. And I and my colleague Michelle Brenner in humanities would absolutely love to have an opportunity to talk with your humanities instructors about how computing can help them do what they do well, but better. Thank you very much for attending, and look forward to hearing from you online.